Okay, great. So today's tutorial, the first one is about ADA, basically. Basically, going to cover like data extraction, cleaning, transformation, and formatting using modular Python. Okay, so it's going to be like something that probably you have done before, like for most part. But let's see if it's going to like help or clarify for some of you, like what you're supposed to do. Okay, so the data I'm going to work with here is a healthcare data set. It's diabetic data, which is it's a data set that covers uh, like hospital visits in from like these years 1999 to 2008. And so it's not the same. It's not the data set you are using, of course. And the goal is this data set is going. So, okay, just this is the first step. What I'm doing right now is just making sense of the data. This is the first step in the ADA, or like exploratory data analysis, is to have to make sense of the data. You have to know like what is basically what the data when you understand the business objective, of course, you know. Sorry, I should share my screen. Sorry. Um, Let me do that. So what I'm talking about is that the first step, like of course, you know, like what we discussed last in week 0, you have these stages in the CRISP DM. You start from understanding the business objective, then you go through like data analysis or like data ADA, and then data preparation, and the rest of the modeling and evaluation steps after that. So okay. So the data I'm dealing with right now is going to be a healthcare data set that covers hospital visits for diabetic patients. And the goal is the goal of the business objective of this analysis is to like create a predictive model to predict how many patients or which patients have like readmission, um, which one have the risk of readmission into the hospital based on the data that is available. So this is the basically in general the basic is the business objective. So this is the data set, or this is the source. So the data set has like you have this, for example, you can see my screen. So in your case, you have like a data set, a table with like, I don't know, 54 or something columns. And there are explanations of each column. So you have to go through this, understand what the data includes. So looking here, like I have like in my data set, I have a CSV file that has like these columns, these fields. I have like an encounter ID. This is like and patient number, like unique identifier of a patient. Have race, gender, age, weight, and then like this is very understandable. But like I also have this admission type ID, which is defined integer identifier corresponding to 9 distinct values, for example, emergency, urgent, elective, newborn, and not available. So you need to go through, understand what the data have. Like, for example, we have time in the hospital, which is an integer of days between admission and discharge. So I know that like the unit of that column is days. And okay, so like what else I have? Like have number of lab procedures, number of outpatients, which is the number of outpatient visits of the patient in the year preceding the encounter, number of inpatient, the number of inpatient visits of the patient in the year preceding the encounter, and I have like diag one, which is the primary diagnosis, secondary diagnosis, and there is like another one like three. Anyway, I can just go through. I understand, like I see, like I understand this. What is the data have? Just a general understanding. Then, of course, once I read my CSV file into a data frame, I can start actually looking at it. So this is the next step, like just like looking at like the head of the data set, the data frame, so I can see um, like I don't even see all the columns because there are so many. So like this is really, but I just kind of have a feeling of what the data set is in have. I can use info to just see like all the columns, and then like the number of non the data type and the non-null variable values. Sorry. Um, so I know like the shape. Again, so I didn't like what is the shape of my data. Let's do this first. Let's see if I can run this. Um, Sorry, I'm missing. Should have done this. First I moved it. So that should be. Yes. Okay, I just want to look at the shape of the. Okay, so I have 100,000 rows, basically 100,001. 101,000 rows and 50 columns, and see like some are really, for example, the encounter ID is really had no null values. Yes. Yeah, so there's a question about the data access. So the data you have is not in a CSV file. It's actually in a data, well, in an SQL file. You have to um, like use Postgres basically to import that database. And then like from there, you can read the table directly into like a data frame as well. So the step will be a little, slightly different, but we'll cover that in the next tutorial. If you don't want, if like, yes. Uh, okay, sorry, sure. I will try to increase the, is it better now? Is it better? Yes. Okay, so the next tutorial is going to cover like how to actually like use Postgres and SQL Alchemy with Python and pandas. But if you want, you can also like read. You have the slides for that. Very simple, very few, like a 3 slides or something that covers how to get the data set from like from the file you have. So I'm going to go forward. So just looking at the data, you can see like I have some none, which is like these are null values in some of my columns. And looking at this output of the info function, I can see like yeah. So this has like the non-null values, which is good. This is an ID, encounter ID. But for some values, like, and you can see, like, for example, this one, like, these are really like almost like almost all are empty. And so probably not going to use this column in my analysis. Okay, so actually to know what is this actually max blue serum, it's like some kind of a measurement of range of result if the test was not taken. So it makes sense So it makes sense that it's empty because there are null values, because like it's only registered for when the test was given, so it's not a mistake. But anyway, depending on like what kind of analysis I want to do, I will have to like consider, like for example, okay, this makes sense that I have null values, but for example, I have the weight here. So for each patient, I have like some basic information, race, gender, and age, which are like all are filled, but the weight is really, most of it is not there. And probably in my analysis for readmission, I'm not going to be able to use this one, use this variable in my analysis. It might be like useful, but it's not possible for me to do. So to do actually this more, looking at them.
So, excuse me.
Sorry.
Do we need for that variable weight? Do we need to change the data type?
Do we need to change the data type? Sorry, let me look. Why is it? It's an object. Yes. So yes. Let's see. Like what it says here. You're right. Sorry. Okay. So the weight, oh, well, for some reason it's categorical. It's probably in like I don't know, maybe it's yeah. So if we want to use it, yes, you're right. It should be a number, so we have to change the data type. But what I was talking about is that the null values are a lot, and then most of the column is missing. That's what I'm saying. So that I'm not going to be able to use it. So just looking at the missing values more. So just doing this, I'm going to get like the sum of null values in each column. Basically, you see like some like, but that's not all. We have to make sure that like this doesn't have like this counts like the pandas is nice is going to count the null values or the NaN. But if like the null values can be registered in a different way, like for example, it's unknown or like missing or like a question mark, then I will have to make sure that like I have to look at the data itself to see that what kind of data I have, so that make sure that these are not really null. It doesn't include null values. And we can do this, for example, let's see. Okay, let me just take an example. Let's take the weight because it's like just because it's categorical, I won't actually look at it. Let's do that. So let's see the number of unique values in it. Of course, it's 9. So let's look at them exactly what they are. Okay. You see, like the unique. So these are the kind of values I have in this column. So they are like ranges, as you see. So so it's really categorical. It's not going to be like we're not going to be able to directly change it into a numerical value. To kind of that, but just I was just saying that I could have found like unknown here, one of the values, and then that I could have like also like treated as a null value or a missing value, and then like that will mix. It will come later in when I'm handling the missing data. Okay. So here I'm just looking at the data, getting a feel of what the data includes. To do like more of this, like you can use descriptive analysis or non-graphical univariate analysis. So looking at one variable at a time. You can use like, for example, the describe functionality in pandas, which is going for for numerical values, it will give us like the mean, the standard deviation, and like different quartiles. So the 25s, 50s, 27s, and the maximum and minimum values. So Tamis Hospital, which is in days, the mean is 4, standard deviation is 2, and the minimum value is 1 up to 14. Okay. I can also do this like more. This is not going to be good because I have so many columns, but I can actually apply it directly to the whole data frame. And it's going to give me like these values for all the numerical columns, right? So in one way. And can note here, and you have this also in the data set you have. For example, the encounter ID, even though it's a numerical data type, it's an ID, so it shouldn't really, we shouldn't like be looking at its distribution, right? It's an ID number. It's just like you can actually change it into like a string data type instead, or something, because it has to be unique for each, and we don't really need to look at its description in this way. Anyway, so the same for patient number. Some numerical values should actually be treated as categorical depending on how they are described here. But okay, this is something that you get from like going through the data set and through the understanding of the data set. For example, admission that type ID is actually categorical because it's codes that refer to a particular kind of admission type. So it's just like it should be treated as categorical, and you should look at the mode instead of the mean and standard deviation, because it makes no sense to have a, so the mean is 2.02, but this makes nothing. It's not, it doesn't make anything because it's actually, so let's look at that. Sorry if I'm, so they are 9 distinct values. So they have like 1 is emergency, 2 is urgent, 3 is elective, 2.2 is nothing. So you have to like be careful about that and like do the necessary data type changes, or at least do the right kind of a summary statistic for each. Okay. So this is like for for the summary statistic part. So let's see how about handling the data, missing data. We talked about this a little bit in the stand-up, and we saw like there are different methods to dealing with missing data, depending on like how, like if it's for some, okay. Okay, let's look at the examples. Yes, this is a function that computes the percentage of missing data in a particular, in the whole data set, or like for a particular column. For example, the weight is missing 96% of its values are missing. Okay, depending on like how critical for our analysis is a column, and how much missing data is there, and the data type, we can like decide how to handle the missing data. For example, going back to my data set, or so in my analysis, I'm just going to go back to just look at this. So I have encounter ID. It's like the identification of a particular encounter. What does the missing data there means? That means there are some errors that happened when the data was entered, right? So maybe I'm not going to be sure that this data that entered with like it's a missing ID, the ID field is missing. That means like I'm not sure that the other fields are correct, and it will make sense for me to drop this record completely. because it's like, it's, I don't know if it's correct or not. If I don't care about that, for some reason, I've said like, okay, have some data. I care about like having as much data as possible. Then I'll say I'm not going to drop any records. I would rather like drop the column that is causing the problem. For example, that instead of like dropping all the records that don't have the weight, because that will going to reduce my data to a very small, to very significantly. I'm going to drop the weight column instead. So I can drop like records or can drop columns. I can also impute the data instead. Just replace it with some value, not drop it, but replace it. So, and for that, like there are several methods. So, so the first one was deletion. So we talked about, there is a filling missing values with the mean, median, or mode. Okay, this is the simplest method. It's not always suitable. So the mode makes sense when we are using categorical data. So we replace the value with the most common value in the data set. In a new for numerical data types, so we can use the mean or the median. There is a slightly difference between them. The median is immune to outliers, while the mean is affected by outliers. Okay, this is if you understand the statistics or the meaning of these two variables. So they are like, they are not always suitable. Or what do they, we have to understand what do they change for you. So the mean will, and replacing with the mean or the median will change the variance of the data set for you, because looking at the data distribution, when you replace with the mean, that means more data are going to be centered in the middle, so that you are reducing the variance. And the same for median. And also it's going to affect any kind of, if you are looking for correlations, it's going to affect the correlation as well, because you're just putting some random variable, sorry, some constant value for all the missing data. So you're not getting, if there is correlation between this variable and another one, you're going to lose like part of that. Okay, so so you have to like keep that in mind when you're doing that. Like there are, another method is forward or backward fill. This is useful for like time ordered data set, or like just ordered data set. For example, stock, in stock trading, the stock price, it will, if you have like missing data for some days, it will make sense to fill the stock price with the value for the day before or the day after, depending, you can choose, instead of like calculating the mean for the whole year and then putting that. So it will make more sense to actually fill it with like close in time values. There are interpolation. So this, instead of just using the value before or value after, you can use like an average or another kind of in kind of combination. There are more advanced methods that will like something that you I don't know, like you can actually use machine learning to actually predict the missing values, or like do some kind of regression to actually, we assume like other values, other variables are related or they're correlated, and you can actually predict the value of the missing one from the others that are available. So you can use that. So these are more advanced, but like these are simplest. It's useful to look at the, before missing or handling the missing values, you can look at the distribution. For one example here, I'm mentioning that when you have a skewed distribution, doesn't matter if it's negative or positive. The thing is that skewed, the distribution means it has a long tail to one side instead of two. For the bell curve, it's like it can have like long tails in both sides, but like skewed data set will have a long tail on just one side. And for that data set means that the mean, because it's affected by the outliers, it will going to be like it will drift with the tail. So in that case, it's useful to better, or it's better to use the median, for example, as a replacement for missing values. So just looking at some data here, you can see I have a tail in my data. Most of the data is concentrated here, but there is a long tail up to here. And so it might make sense if I want to replace values in this column is to use the median instead of the mean. Okay. Of course, there are like pandas functions. You can just calculate the skewness directly, and you see like this has a huge value compared like if it's small, it's fine, but okay. Can see directly which ones have big numbers. So looking at the distribution for this one, so that's the number of medication. Let's actually look at the number of emergency just to see how it looks. Sorry, wrong number. Yeah, so yeah, most of it is actually exactly, it seems like it's most of it is exactly 0. And then there is a very long tail up to 70. Just look at, it's not even clear here in the plot. Just like it can also be clear in the, that is the summary statistics. And see. Sorry. So you can see that the minimum value, the like up to the 27th quartile is 0. And then suddenly the maximum is 76. So as you see, like all of the data is here. And then suddenly there is an outlier very far away. So this will this leads us to the outlier. Let's skip this part. Like there are yes useful pandas functions for filling the handling missing data. You can use that, and yeah. So actually, it's not here. So we can actually also have to deal with the outliers. Again, handling the outliers is like a judgment call. Depends. Sorry, going. I'm looking for something. Sorry. Okay, so it's still also a judgment call to handle the outliers. Um, so you have to think about what the outliers mean. What does the outlier actually constitute an error, maybe, or do you want to? So, and then do you want to eliminate them, or do you want to keep them in the data set? So it's really a judgment call when it comes to that. So you might think, for example, in our case, that in this number of emergencies, this outlier is someone who's really not representative, or like not represented. This is really a strange case, and going to just remove that patient from the data set and deal with the rest, because my predictive model is not going to work with these extreme cases. Anyway, in some cases, maybe the outliers are. I'm trying to think of a case that where you want to keep the outliers. But anyway, you can also handle the outliers by removing them or imputing them also. So it's the same thing, like there are same options kind of when it comes to outliers as with missing values. Okay, so yeah, so a good thing to like I'm talking a lot. So one if you tell me like what I can use visualization to actually look at outliers. Can you suggest like a type of graph to use to see the outliers clearly if the data set has outliers or not? Like looking at a particular column. Yes, Jabez.
Maybe use a box plot.
Yes, box plot, exactly, that's correct. Box plot exactly shows us the outliers in a data set in a like a column. So let's see if there is an example here. Yes, exactly. So uh, of course, in statistics also we can look at the yeah. So this is a box plot for the time in a hospital, and you can see here I have outliers. So if you know what the box plot has, this is the median, and these are the 25th and the 275 quartile. Okay, so and these values are very far from that. So they are really in the distribution they are quite far away. So the box plot is exactly useful in seeing outliers if the data set has outliers or not, and how many are them like there. Yeah, so there are several here, several examples. Have here more, and let's can also like see like if it's extreme or not. Okay, and here we have a function to fix the outliers. Just let's the code just to remember. It actually was removing them all completely. So utility functions here. So yeah. So here in this case, we use the median. We replace the outlier with the median. It's a choice. We can also choose to drop them if there are not too many. And for here, actually, there is another thing. Besides also handling them, we also defined what is an outlier. So the outlier here is defined as the one that is exceeding the 95th quantile, right? So the one that is greater than 95th percent of 95% of the data set. And for that, I'm replacing it with the median. Um, okay, so this is a choice. Of course, I can change this to a different definition. Can use like 99 if I want to be like really keep as much of them as possible. I can reduce it if I really want my data to be like more concentrated. I can choose to drop them instead of actually replacing them with any value if that's like what I want. So depending on the case. So you have to, like when you look at your data, when you're doing your ADA, you have to like try to reason, try to think about it, and include that reasoning in your report, and like in your like, and also can write it in your notebook. I'm choosing to do this so that you can actually, if you come back or if you like explain it to your like employer, like I did this for that reason and it like gave me this result, and maybe if I handle it differently it will give me a different result. So I'm just saying like document what your choices and try to reason, like motivate why you are choosing what you're choosing. Anyway, just let's move on. So there are like dealing with categorical variables, like it's just the same with just like using mode for imputing the missing values. We can also like look at in our like univariate analysis, you can look at the distribution and like actually use KDA. This is approximation for the actual distribution. So from like these discrete values. Okay, we have already talked about the outliers. So it comes to the multivariable analysis, we're going to be looking for correlations, if there are. And we can just start by like plotting stuff in scatter plot, different different variables together. For example, like we wanted to see like the number of medication with the number of lab procedures and plot them for different trays to see if there are different. It seems like it feels like there are some kind of correlation, but maybe it's a weak correlation because the data is not concentrated so much. But it seems like there are some. It's possible. So the goal of this is to look for possibilities and to look for like which features are important, for example, and in their relation to each other, and to the one that you want to really predict. Okay. So can do different like types of multivariable analysis. So we can also use like multiple plots at the same time. It's okay. This is not really. Just here I'm comparing the distribution for gender, for the number of medication. You can see like for females, the median is higher and the distribution is more concentrated than the male one, and this is like different for like unknown gender, which this one we didn't remove in from the missing data. We left it there in this case. So so there are pair plots. It's another thing you can use also to look at. And you can see some of them is not really, they are not really useful so much. If you don't find correlations really, and that's fine. You have to look for, and it's fine if you don't find a lot. Anyway, this is going to be useful for like, there are other things we can do later on after the ADA in the data. Sorry if I'm talking and not showing anything. But later on, there will be like the step of data preparation where we can do like feature selection and like maybe dimension reduction. To basically, you are going to be selecting the features you're using for analysis. And when you're looking for correlations, it's useful to just get a feel of which features are actually important and which are not. So which features have some kind of a correlation with it. You can come with a hypothesis when you're looking at it, like, okay, it seems like maybe the gender affects the readmission probability, and then I'm going to include that in my features. Maybe like, okay, it's just like you get the idea of the goal of doing that. So the last step we're going to talk about here, and then we can like turn to questions if possible. So it's data transformation. This is another thing that you can do. You have the data. We talked before about like changing the data type. But another thing you can do is actually affecting the values themselves. This is something that of transforming the data. So there is standardization, normalization, and dimensionality reduction. So dimensionality reduction, you can choose to like reduce the number of features you're considering to a lower number. So before moving on to like modeling later on, so it's better to have like if you can reduce the dimension of features, the more like you reduce the features, as long as you keep the important ones or like the most like significant ones, or all the ones that are necessary while also reducing the number of features that is good for like when you're doing machine learning modeling. Sorry, is the question? Yeah.
Must we always transform our data before modeling?
Yeah, so this is part of the data preparation part.
Okay.
Before doing the modeling.
Also,
yes.
Also, when constructing the pipeline, do we transform the data before making the pipeline or in the pipeline?
So the pipeline is going to have, you're going to just include like what you did in for your data. So if you did some kind of data cleaning, then some transformation, you with like a scikit-learn library, you can actually construct a pipeline that includes each of these steps together. And then you can like basically use the pipeline to apply it to the raw data and get to the process data right away. Or actually, I will include actually the modeling as well. So let me say this: when you start, when you are just exploring, when you're doing, you don't know what you're going to do. You don't build a pipeline right away. You start by looking at your data as I was doing right here, just looking at it and try different things. And when you decide on what you're going, how you're going to prepare your data, how you're going to clean it, how you're going to handle the missing data, for example, how you're going to transform it using like normalization, for example, if you're going to do some dimensionality reduction, if you decide the steps, then you construct a pipeline and include these steps in it. I wish I had like like I can view this, but do you get the idea?
Yeah.
Okay. All right. So just briefly, I'm going to talk about like what standardization is, what normalization is, or um, actually, let me ask you, or can one of you like define what normalization is and what standardization is? Sometimes they are like used interchangeably. So if you have like what a feeling of what they do.
Okay, yeah. So from the top of my head, I think when you when we talk about normalization, I think we're talking about balancing the variance between your records or your figures. Such that when you feed it into the machine learning model, the model does not give a false performance due to one number being superior than other. That's from the top of my head.
Okay. Yeah, you're almost there. It's almost correct. Yeah. So yeah, so you're right on the reason and you're right on the general idea of what you're doing. So you're changing the values of the for like the variable. For your data set, basically in the normalization part, you're going to be changing the value such that the mean is 1, the mean is 0, sorry, and the standard deviation is 1. So this is the normalization part, the standardization, sorry. The normalization is you're going to be changing your values such that they are restricted between 0 and 1 or -1 and 1. So you are just like doing some scalar transformation on your data to do this. And the goal, as Joseph mentioned, is that so that like you do this so that the machine learning algorithm doesn't give weight, or let me say this, if you don't do any kind of normalization or standardization, and some of your variables have very big value. So because when you enter your variables in the machine learning algorithm, the machine learning algorithm doesn't know about units. It just looks, it's just like dealing with the data as numbers, right? Even your categorical data, you have to change into numbers when you're doing different kind of machine learning using the different kinds of machine learning algorithms. So for numerical values, if you're looking for like some kind of regression, if you're looking to measuring some kind of a loss function, the variable that has a big number, just a big scale, is going to have just affected is going to have big weight on the value in the end. And this is just a spurious thing. It's not necessarily true that this variable is really important. It's just like because it has a big value and the others are small compared to it, it's just going to have a big weight. So you do this to avoid, to like get rid of any kind of spurious effect for the variables. So you standardize or normalize all of them so that the values all range like between 0 or 1, so that like, okay, if they affect, they really are important, the importance is going to be real importance. It's not going to be just because of the scale. And this is true for both the supervised learning and unsupervised learning. So, or like, sorry, for, I mean, I meant for like a neural network or for like other machine learning algorithms. This is both true. I mean, the effect is different. It's just the weight here in the and in the neural network is the idea is that it's just going to be, it's going to slow down how the like the algorithm converge. Okay, so yeah, so there is a difference between normalization and standardization, but it's just like as I said before, one of them is just setting the mean to 0 and the standard deviation to 1, and the other one is restricting the values between like 0 and 1, or you can actually choose to make it like it's usually like 0 and 1 or -1 to 1, but you can actually custom define them if you want. Okay, so there are examples here, but okay, I'm not going to, or rather let's look at it. So they have like this distribution, there's some distribution of my data, and you can see the values are from 0 to like 1 or almost 2000. It's like it's really small, very long tail. And then after scaling the data, so you can see the values now change to be some with negative values and some positive, but they are really limited in values. So it's up to like less than 10, and negative is less than -2. And the mean you can see is around here. And the standard deviation of this value, this distribution is 1. So this is the standardization, the normalization. Let me, okay, I have to, there was a mistake here. I'm sorry, just let me try to run this. Sorry, it's like taking time for now. Okay, so same, because I just want to change this because it was wrong, mistake. Yeah, okay, you can see like this is the original distribution, which was from 0 to 1200, and now the distribution is from 0 to 1. It looks like the same distribution, right? It looks the same, but just the values are different. Anyway, that's all. Any questions? Okay, Sheila.
Hello, I wanted to ask, through the data cleaning and what we have talked about, when we came, everything we're doing before, we're doing the cleaning before we do the EDA. But what about the data transformation you've mentioned? We're doing it before we do the modeling. Does that mean we also do it before the EDA?
No, okay, so the handling of cleaning the data is part of the EDA basically, because to actually do to clean the data, you have to look at it and see if there are missing values or not. This is part of the EDA basically, but this is a definition. But all of these steps come before the modeling. Okay, and the thing is that these are choices. You can actually model, you can actually choose to do the ADA or like process, let's say, process your data, reprocess your data in a way, doing like handling the data, the missing values in one way. Let's say you drop them and then transfer, not, you say drop the missing values and didn't transform your data. You didn't do any kind of normalization, standardization, and then you did some modeling and you got some results. Okay, you evaluate this result, you like how to say, you can like document or like document the result of that experiment. Like you can, like there are these tools to do this. We're going to discuss this in a later tutorial as well. Anyway, you can do this and then come back. Okay, say, okay, maybe I can handle this differently, and come back and deal with the data set in a different way, handle the missing data in a different way, and then transform the data, and then see what you're going to get. So if there are reiterations, you can do this, like come back, as we discussed before. It's not just a one-way street. You don't start with one step and do the next one and you never go back. You can go back and do it in a different way and see what is the result you're going to get. Is that clear? Does that answer your question?
Yes, but to be clear, you've said that the data cleaning process is part of the EDA. It's part of the EDA.
Yeah, so sorry. So that sometimes the naming is confusing from one person or one, like looking at the resources. Sometimes they call ADA a different part. Like sometimes they include the cleaning, sometimes they don't include it. But in the way you are using it here, let's say in the I think in the document challenge, ADA is all of this. So cleaning the data is part of the ADA. Looking at the data, looking at the correlations, all of that are part of the ADA, basically. So it's just like the steps are the same, but the naming sometimes are different.
Okay, thank you.
No problem. Yeah, so next, let's see. Jolie?
All right, thank you for the lecture. But I just want to clarify some parts of it about the concept. Can you please break down into the different concepts? Like, are we doing data engineering in it as well? Which aspect is data engineering? Which aspect is machine learning? And which aspect is AI engineering? So we can easily know this one we're doing is based on the concept of data engineering, and this one is for machine learning. So that when we're picking feed, we'll know the one we will be more like we've covered in a nutshell.
Okay. All right. So which part is which role? That's a good question. And again, I'm afraid that the answer is not always the same. But let me clarify. So the what we're doing right now, the ADA, is usually like it could be part of what a data scientist do, or a part of what a machine learning engineer do as well. They can also start with the ADA. The data engineer role comes before that. So the data engineer is responsible for like building the pipeline to getting the data itself. So this analysis is usually not part of the job for like a data engineer, but so this is just general idea. So let me, if I can open the graph for a second. So the qualification, or like the but part, comes with is that sometimes, depending or like the size of the company or the size of the team, sometimes just one person will do everything. So, so it's not depending on how specialized the team is, as the roles will be. So just to clarify the question, 1 second. Clarify my answer, sorry. I'm going to, right, so it's here. So just to share my screen for a second, just to show. So yeah. So this is the crisp. Remember this one we had in week 0. And so these are the stages. Let me just read this a second. So you start with business understanding, data preparation, modeling, evaluation, and deployment. And okay, so these are the stages that you go, like you can do iterations, as we said, like you can start going in order, but as you reach the evaluation, you can go back and like do this again. Okay. This part, like the ADA falls kind of here. So it's between data understanding and data preparation in a sense. And so the roles for like a data scientist will be like from here, data understanding, data preparation and modeling. The machine learning engineer will be like it's here from like maybe from modeling to deployment, because they are responsible for deployment. But so there are some overlap between the data scientist and the machine learning engineer. But again, as I said, in some organization, it might be like they only have a data scientist, or they only have a machine learning engineer, so they will be doing everything. And a data engineer role is kind of outside of this. Is like or like a building that pipeline that goes brings the data to be analyzed, and basically just like building the pipeline for the data going in different parts. So okay, I hope that I answered your question. Is that clear?
Yeah,
Okay.
it's clear. It's fine.
All right. And it will be clearer to you with like when like this is a machine learning project. Later on other weeks we're going to do like AI and data engineering projects that really specified for that, and then you're going to have a more understanding of what each role, which skills are needed for each role, and which more. But there are a lot of overlap, so that's why they are grouped together in this training, and why you are all doing all of these projects together. So because there are a lot of overlap, and you need to either be really able to do these different tasks as well, and also at least have a good understanding of what the other roles have to do, so they can work with them, regardless of what you choose in the end to your career to be in. Let's move on to other questions. We are over time. Sorry, let's take a few questions. Hilary?
Yes. I have a question that I saw a dimensionality reduction, and that is after from the data transformation. Are you supposed to do both the standardization, normalization, and also that one, or do we choose one for dimensionality? I mean, because the
Yeah.
essence I think is to bring the data to a common scale.
Okay, so yeah, so to clarify, standardization or normalization, you do one of them to basically control the scale of your data. Dimensionality reduction is a different thing that you can do after that. Dimensionality reduction is basically you're doing a feature selection. Basically, you start with a number of features, a number of dimensions. Let's say you have in your data, you have 10 columns or 10 features. And so you want to input that in your machine learning algorithm. But what you can do is actually you use dimensionality reduction and reduce these 10 dimensions or 10 features into, let's say, 3. Maximizing the if you know what dimensionality reduction is, you are going to choose different in the vector space. You're going to use a different a base that along which the variance is still maximized. So the basic idea is that the dimensional reduction reduces the number of columns or the number of features you have while maintaining as much variability as much information of the data as possible. So if you really have a lot of, so you can choose to do that or not. So if you have a number of features like 10 and you want to like, okay, I'm going to use all 10, and you can go ahead and do that. But if you think or you suspect because of how you look at the data that some of these columns are redundant in a sense that some columns include kind of the same information as others, but in a way that you cannot really eliminate yourself right away, you can use dimensionality reduction to actually reduce the number of features you have and do that. Sometimes all you want to do is that, or what you want to actually just see, like which features are really important to predict your whatever, like your target variable, and so that it's useful to do dimensional reduction in those cases. Okay, is that like, does this answer the question or give you like some kind of basic understanding of this?
Yeah, it gives me a basic because one thing, let me say this. I did the PCA and I got like, say, let's say 14.3 and 2% for CA to 1 to 6. I don't know what it means, but it says, let's say they are related or something.
Yeah. Okay. Let me see. I remember actually what PCA, but okay. All right. So was that part of like maybe one of the tasks actually asking you to do dimensionality reduction?
Yes, it was in task 1, task 2.
Task 2. Okay. Yeah. So this is a basic understanding. You can read more on it. I suppose there are maybe some. If there are no references, we can actually provide references on dimensionality reduction. Or just because we're running out of time, we can expand on that later on, okay? Or you can ask also on Slack if you want. Okay. Another question? Komi?
Yeah, thank you. I'm a little bit confused about how do we call this? The task 2. You provide us some details about the task 2, and then I'm not finding myself between the context and the different step that we should follow.
So what exactly is like, what is the confusion, or like what's something that you don't understand in particular? What exactly?
Okay. There is a part where you ask to start by identifying the top 10 handsets used by the customer.
Yes.
And then I think task 2.1 is asking to aggregate the data per user.
Right.
Okay, so when I look at the different steps from task 2.1 to task 2.2, I can't see any. I think yes, I can't see anything related to the handset or the manufacturer.
Okay. Yeah. Okay. Right. So yeah, it's not that right. Maybe it's confusing how it is structured. You can consider this the part about the handsets as like a task 2.0. It's not the goal of the whole task 2. It's more like starting like these are questions that you can start by answering these questions, and then
So we should answer this question first before going to the task of 2.1, right?
you can, yes, you can. So basically, yeah, the task 2 in general wants you to do like user overview analysis, meaning it's ADA focusing on like the user. So it's basically ADA. So and these are, what do you say, minimum things you can do, or like suggestions what you can do. You can actually go, if you want to do a deeper analysis or like a more extensive analysis, you are really encouraged to do that. But these are questions you can start by answering. Think about answering these questions and doing that and think of, you are encouraged to think of your own questions if you want, or if you notice some trends or some correlations, and you come up with more questions, that will be also very good. But yeah, to clarify, yeah, this is starting once about the handsets. These are just like, let's say this is task 2.0. It's like the first task. It's not the goal. Right?
Okay. So the second question that I have is about task 2.1 and task 2.2. Like the task 2.2 is asking to conduct the exploratory data analysis on those data. But from task 2.1, we aggregate the data per user. So I was wondering, do I have to use the data that I get from task 2.1 after aggregation, or should I use directly the data that I clean first?
You use the aggregated data if the question like needs the aggregated data. If it's not, you have to use the original one, right? So I think yeah, the aggregated data is only for this 2.1 and the other one, but I'm not like, let's see. Yeah, so the 2.2 doesn't need, you don't start with the aggregated data. So like, you're going to use the original data to do, I think, maybe all the questions. I'm not sure. No, wait a second. So you are aggregating by user, right?
Yeah.
And so I have to, because I have to go through like the questions themselves. It depends. It will depend on what is the question. And so the question is what? So I'm trying to read, sorry. Yeah, well, from what I'm reading right now, and maybe some of you, maybe someone else of you, like have maybe started to do this. But from what I'm reading, you don't need to use aggregated data to do the 2.2 part. So because you're going to just look at different relationships, we are going to start by looking at the distribution, at so doing some non-graphical analysis and graphical analysis as well, a correlation in the end. So you can be using the non-aggregated data for that. Okay, but I like, how about that? I'm not mistaken. So someone like Hillary is saying like, okay, so Hillary is saying that yeah, they did it without aggregated data. Yeah, so that's what my understanding also, like from like the questions, reading the questions right now. Okay. Komi, is that the answer to question?
Yes, that's good.
So okay, so because we are over time, let's stop here. And if there are more other questions, you can ask on Slack. And we have a later on, we have a tutorial later on about using SQL databases. And so we will meet later. Okay, so thank you for attending, and thank you for your patience. And have a nice